Hi again, and today's session is focused on the use of comments and different data types in our code. Our project from our last session is still up on the screen here, so let's just use this project to illustrate today's topics. So the first topic that we're going to be discussing today is comments. Now, a comment is basically a line or multiple lines of text that are inserted into the source code to explain what the code itself is actually doing. For C++, there are going to be two types of comments that we can use. The first comment is going to be these two double slashes here, which will begin a C++ single line comment. And what this does, it tells the compiler to ignore everything up to the end of this line. So I can be like, writing my first program here. Also, I can put a single line comment at the end of a statement here in our program. And I could put everything from here to the right of this line is ignored. So typically we use this double slash comment above the line or above the statement to give it easier reading in our code itself. The second style of comment that we can write is the multi-line comment. And what this does is basically allows us to write multiple lines that are going to be treated as comments. So to start this, we're going to do /star, and we can see Visual Studio is put in the closing part here, which is going to be // and we can write anything in between this /* and // and it will be treated as comments in basically. So I could be like, this is a multi-line comment. This line will be ignored. So will this one. As a rule, do not nest comments inside of other comments. What this means is that you do not want to put comments inside of other comments. So for example, I will not want to do a single line comment inside my multi-line comments. This is bad practice. You either use the single line comment or the multi-line comment. You don't mix and match the two of them. The comments are typically used to describe what is the purpose of the code at a particular line or statement. And it is also possible to comment out lines of code that you do not want to be executed within your program. So just to illustrate this, if I build my program here, so I'm going to build the solution. And then I'm going to go debug, start without debugging. We can see here that when my program executes, or runs in other words, that the two lines here, being hello world and hello again, is going to be outputted to our screen here. And we can see that all the comments here are basically just ignored once our program is compiles and runs. Let's say I don't want this second line here to execute, but I still want to keep the code in case I do want to execute it later on. So I can just put a single line comment here that will just basically comment out that entire line itself. And once I build my project and start without debugging, we're going to see that only this cout hello world part here is going to execute. So my program is up and running here. And we basically see that only the hello world statement here for the output is going to show. And it's going to ignore the hello again statement because we commented it out. So this is important in case that we may need this line of code later, or if this particular line of code may have a problem that requires fixing later on. So if I uncomment back this line of code by removing the double slashes, if I rebuild my program and start without debugging, you can see our program runs as expected with our two lines of code here being executed. Now moving on to variables. A variable in C++ is simply an object that has a name. To create a variable, we need to define our variable with the associated data type. We can then initialize our variable by putting the associated data into it. So for example, I can type in int x here, and then say x is equal to 5. And it's possible, instead of just doing these two steps here, I can do this as 1. So I can say int x is equal to 5. So one thing to note here is that a variable can only be initialized when it is defined. If a variable is not initialized, the compiler will assign a random value to it. So it is recommended to always assign your variables to an initial value of your choice. And typically, if you don't have an idea what value to assign it to, we put that at 0. This reduces the risk of errors later on within your program. Now, there are different data types we can use to create different types of variables. We will look at each one of these in turn. So starting with this first one that we did here, our first data type here is int, which is basically short for integer. We saw the use of this for our main function already regarding its return data type. When we use it within the body of the main function here, we basically created our own integer as a variable named x. If we wish for our program to output this variable, we can use our cout statement to output the variable to the console screen. So we basically can do this by saying std_cout, put the angular brackets, x, and we can just put the end line here, because we're going to be outputting more variables later on. And we can build our project and start without debugging. And we can see here that the value of 5 is outputted to the console screen, which is stored in our variable here, x. And 5 is basically our integer data that is required. As you can see here, the contents of the integer variable x is outputted to the console screen. Now remember, integer here is basically a whole number. What happens if we try to put a decimal number instead for our integer data type? So let's try it and observe the effect. So instead of 5 here, we're going to put 5.5. Or I'm going to close off my program here as well. I'm going to build my program again and start without debugging. And you can see here that only 5 is outputted to our console screen. And this is because the variable here is an integer variable, and thus it can only output a whole number instead of a fractionalized or decimal number. If we want to output the entire decimal number, we need to change the data type to the associated decimal data type which is required. And there are two data types that we can use here in order to achieve this. So I'm going to put this back to 5, and I'm going to introduce the first data type that we can use here for decimal numbers, which is float. I'm going to name this variable here x2. I'm going to say 5.5. And right after my first cout statement for output of x, I'm just going to highlight this entire line here, right click and copy. Go on the new line right underneath it, right click and paste. And I'm going to switch this from output and x here to x2. I'm going to build my project again, start without debugging. And we can see here that x is outputted, which stores a value of 5, and x2 is outputted here, which stores a value of 5.5. Similarly, if I don't want to use float, I can use double, which does the same thing, representing our decimal data. I'm going to rebuild and rerun my program here. And you can see that we achieved the same outcome as before. So the float and double data types here will output the entire decimal number as required. Now note that variables here must have unique names. If they do not, the variables themselves will be overwritten when later statements execute in your code, or your program will not compile at all. So we're going to try this and see what happens in particular. I'm going to switch this from x2 here to x. And I'm also going to comment out my x2 line here because we no longer have an x2 variable. I want to build my program again. And we can see here in this particular case our build fails. And if we read our errors here, we can basically see that a redefinition is not going to be allowed, and thus our program will not compile at all. So I'm going to put this back as x2, uncomment this line here, and rebuild our solution. And we can see everything is fine, build 1 succeeded. So this is the importance of making sure that your variables always have unique names. The next data type to be introduced here is going to be char, which is short for character. As its name says, this variable contains a single character from your keyboard. So I'm going to create this char variable here, and we're going to name it x3. And we're going to store a single character on our keyboard here, which is going to be encapsulated with single quotes. And I'm going to output the exclamation mark for x3 here. So I assign the exclamation mark to our x3 variable, which is a char variable. And in my output statements here, I'm going to copy and paste this again and put x3. I'm going to build and run my program to see if it outputs as expected. And we can see here that I got my exclamation mark, my output's an x3. Now note that for a single character here, we use single quotes. But for multiple characters, like in the case where we output in hello world and hello again, we use double quotes. And the importance of this is that for a single character, you will always use single quotes. But for multiple characters, you will use double quotes. Now some bright spark here is going to say, so we are able to output one character, but what about for a bunch of characters in a variable? So we will get to that in a later video session, showing how multiple characters can be used with the char data type, as well as a more convenient data type that can be used to store these multiple characters and makes it a lot easier to output as well. The last data type for today is bool, which is basically short for Boolean. Boolean is a type of logic that can only take two values. They will be true or false. A true in C++ is usually represented as a 1 or any other non-zero value, whereas a false in C++ is always 0. So we're going to create our bool variable here, and we're going to name it x4. And we're going to initially assign a value of true here. And I'm going to copy and paste my output statement and output x4 here to our console screen. And let's observe what the output is going to look like. So we're going to build our solution and start with our debugging. And we can see here that when we output x4, we get a value of 1. So as stated previously, a true in C++ is usually represented as a 1 or any non-zero value. Let's switch x4 here from being true to false. And let's observe what our output is going to be after we build and run our program. And we can see here our output here is 0. So a false in C++ is always going to take a value of 0. The Boolean data type is important because it allows us to control our data flow within our program. In later sessions, we will see how it allows us to implement choices within our program to execute different sections at a time. So that's it for today's session. The introduction of these data types is going to play a very important role later on when we start writing more code. In our next session, we will look at how we can accept user input from the console screen, as well as how we can do operations on our data contained in our variables. So until then, take care and be safe. I will see you guys later.